Hello, and welcome to the main dashboard for the Seven Bridges Cancer Genomics Cloud, powered by Valsera. Here, you'll have access to publicly available data, tools, and more. Let's take a look around. On the left-hand side of the screen is a space for projects. These are all projects that I've either created myself or that I am collaborating on. You can also access these projects by clicking on the Projects tab along the top blue banner. On the right side of the screen is a window for displaying recently completed tasks, or, on the other tab, recent Data Studio instances. Scroll down for some helpful information on getting started. Here we have links to helpful information like the Quick Start tutorial or several other guides. You also have the option to hide this once you become comfortable using the platform. If at any point you feel that you may need help, find the blue question mark button on the bottom of every page. Once you click this, you'll be given context-specific links that vary to reflect what's on your screen. You'll also be able to contact our 24/7 support team who can help you with your next steps. To get started on the CGC, navigate to the top blue banner and select Projects, and then Create Project. You can also find this button along the very bottom here. Once we select Create Project, you'll be asked to give this project a name. And then select whether this project will contain controlled data. If this is checked, you'll only be able to invite members to the project who have the proper permissions. For now, I'm going to uncheck this and not use any controlled data. You'll select which billing group should be associated with this project. Just a reminder to everyone, if you register for an account on the CGC, the NCI provides $300 worth of cloud credits as pilot funds. Then you'll select execution settings. So you can keep spot instances on or off. The reason to keep them on is they can significantly reduce the cost of your task. And then you can also select this reuse option. What this means is that if you are running a multi-step workflow that fails on, say, the second to last step, you don't have to start over when you rerun it. It'll just take the last successful step and move forward from there. There's also an option for advanced settings. So you can choose to block network access or allow network access. If you are planning on using Docker or downloading R packages, you should select Allow Network Access. Once you're ready, click Create. From here, you'll be taken to a new project space. Again, on the left-hand side, we have a description. So you can easily modify this description by clicking Add Description along the bottom. And then this space allows you to type a description in Markdown. If you're unsure what that looks like, you can click this link for some information on how to do different styles. For now, I'll just do hashtag for a heading and then say, this is a new tutorial project. Once you're ready, click Save, and there you have a new description. You can also invite members to this project. So click on Invite New Members to easily invite anyone by looking up their email address or username. So I'm going to invite my colleague Sarah, for instance. I can choose to give her write, copy, or execute permissions, as well as an admin permission setting, which is all of the above, plus she can then add her own members. I'll just leave it at write, copy, and execute and click invite. Now she's a member of my project. You'll notice some additional tabs along the top here. We have Files, Apps, Tasks, and Data Studio. So let's first click on Files, and this will take you to a new page where you can add your own files or search for publicly available data. So if you'd like to search publicly available data, you can choose to use Case Explorer or Data Browser to look up repositories like TCGA or Target. There are also public files that have been uploaded by users as well. There are many ways to upload data. You can move files from project to project. You can connect a server. You can also connect a volume or import from a manifest, say if you'd like files from the Genomic Data Commons or the Proteomic Data Commons. For now, let's click on Case Explorer and Data Browser. Let's go to Data Browser. Once we've selected Data Browser, you'll have many options to choose which dataset you'd like to look at. Again, as I mentioned, we have TCGA, Target, CPTech, and more. For now, I'm just going to select TCGA to show you that. Once you're ready, select Explore One Selected. From here, I will start with File. Once I'm ready, I can select Investigation and narrow it down based on the investigation name. So let's say for this example, I'm interested in looking at breast cancer cases. I can select breast cancer and filter. Now you'll notice that the numbers here for file and investigation have been crossed out. So because I selected breast cancer as the investigation name, we went from 33 different investigations to 1 investigation. We can further refine this as well. So let's click back on File, and let's say I want only open access files. I can click to filter by that, and again, these numbers have changed. We went from 53,000 files to 23,000 files. We can further refine this. Let's say experimental strategy that I'm interested in is RNA-seq for this. I can filter, and now I have 1,231 files to choose from. Once you've filtered to your liking, you can select Copy Files to Project, and then select which project you want to move them to. I'm going to move these to the tutorial project that I've just created. I'm going to add a tag that says TCGA so I can easily identify these, and maybe RNA-seq. However you want to label these is fine. Once you select Copy Selected Files, you'll have a pop-up that says they have been copied to your tutorial project. So we can either click on this link to get back to our tutorial project, or go back to the Projects tab along the top banner and select Tutorial Project. Either way is fine. Again, let's click on Files, and you'll see all of the TCGA files we selected should be in this project. Let's explore apps. So apps work kind of the same way. You can create an app, or you can add apps from our publicly created apps. Or you can create an app, or you can add apps from our public apps gallery. So let's first look at the public apps gallery. Once you select all options, we have over 800 public apps to choose from. You can either search for an app of interest, let's say alignment, just to see what comes up, or you can look through the type and category. So if you're interested in, say, AttackSeq, you can click on that, and these are the public apps that are related to that analysis type. Clicking on any of these public apps will take you to a new page where you can see how the app was created, as well as you'll be given a description and common use cases. You can scroll down, and most of our public apps include performance benchmarking, so this gives you an idea of how much it'll cost to run this app. So as you can see, if you input two 45 gigabyte sized files here, it'll take about an hour and a half and cost $3. There's also API implementation that is offered in this app. Lastly, if you scroll down, you'll kind of see how the app was constructed once again. So you'll see the different ports. So these are the different input files, different app settings that you can change, and the expected outputs. If you don't see an app that you like, you can go back to your project tab and create your own app. Once you're logged in and in a project space, we'll navigate to the Apps section along the top banner. To create a new app, we'll select the button on the top right corner, Create App. From here, we're given two options. We can either create a workflow, which strings together a series of apps, or we can create a command line tool. We're going to select the latter, create a command line tool. Let's give this tool a name. It can be anything, but it helps if the name is descriptive. I'll be showing you a simple tar tool, so let's call this one tar extract. Once we've named our tool, you'll be taken to a new screen, our app editor. There are three tabs along the top of the page: App Info, Visual Editor, and Code. We'll check those out toward the end. For now, let's focus on just the Visual Editor. The first thing you'll see is a section for a Docker image. Docker is an open source containerization technology based on Linux that allows developers to write, operate, and bundle programs. Basically, it's a package that contains everything the application needs to run. For our tar tool, we'll need Linux, so I'm going to use an Ubuntu Docker image. To learn more about how to utilize Docker containers, or if you have any questions, you can reach out to our support team or visit us in office hours. I'll include the information in the description of this video. Our Docker repository will be using an Ubuntu image. Now the next section asks for a base command. Luckily, our example is quite simple. We're just going to be using tar. So I'm going to click on Add Base Command and type in tar. The Argument tab allows us to modify our base command with any additional commands. I'm going to click on Add an Argument, and here I'll be using zxvf in the value space. So the Z means the file was compressed using gzip, X means we're going to be extracting the file, V is optional, but it can be helpful when troubleshooting, and F allows us to specify the file name, which will be taken from the original file we're operating on. Once we've done the hard part, we just need to specify an input and an output port. Click Add an Input to specify what the app should expect to operate on. So in our case, it'll be a file. You can give the input any name you want by modifying the ID. I'm just going to leave this one as input. Next, we'll specify an output. Again, we're expecting to get a new file as an output. Here, I like to set the globe as an asterisk. This means we'll capture all generated files as outputs. You can be really specific here if you're only looking for a certain type, though. If we keep scrolling, we'll see additional options. I like to add a hint, and from here I select SBG Save Logs. So this will save any error logs, or just logs in general, while we run the app. This is really useful for troubleshooting. And for more complicated apps, we can include additional files, like an R script, or maybe something in Python, or specify environmental variables. Once we're ready, we can click Save. I like to add notes to myself so I can follow my progress along the way. Now that we've saved our app, let's scroll back up and check out the other tabs. In the App Info tab, we're able to give the app a description and describe some of the characteristics of the app by assigning it to a category or listing authors and licenses. So I'm going to edit the description here. And click Save. If you scroll down, you'll also see some of the settings that we've assigned. So here we have the input, some of our app settings, which we have not assigned, and outputs. The visual editor you're now familiar with. It's where we built the app. And lastly, we have our Code tab. This is useful for people who want to write their app directly in CWL or Common Workflow Language. Luckily, all this code is auto-generated as we build the app using the visual editor. But it's still there as an option. Once we're ready to test our app, we'll click Run. Here you'll be taken to a new task page. You'll have the option to select a file for input, and then you'll click Run. So let's find a file to input. Remember, this is a tar extract app. So let's search our public files for something that is archived. So I'm going to be searching here for .tar.gz. And because I'm testing this, I'm just going to use a small file. This one is only 115 megabytes. I'm going to save selection, copy this into my project, and I should be ready to click Run. You'll see that this app is queued, but once it initializes an instance, it will run for us. Wait a few moments and head back to our task page. We can see that the status is now complete. We can click on the task name to get more details. So here's the original file that we input. There were no app settings to modify, and 2 files were output, both of them FASTQ. You'll see that it took a total of 2 minutes and cost 2 cents. If you'd like additional information, you can always click on View Stats and Logs. From here, you can see the progress as this app was running. So you can click on tar extract, which is the name of our app, and see that the first section was taking in the input file. This purple line represents initializing of the Docker image. The green here is the actual app running, and then this represents creating the output. Again, you can click on any of these and click View Logs to learn more. Here you'll see job error log, command log. You can feel free to explore. Next, I'll show you how to edit an already created app. For our next lesson, we're going to modify or edit an already existing app. In this example, I have created a tool that generates PCA plots using R. It's called PCA Tool. Let's take a look at it. I'm going to click Run to show you what this app looks like. Here we have an option to input a dataset. There are no app settings, and we can expect some type of output report generated from this app. I'm going to show you what it looks like in the visual editor. So let's go back to the apps, click PCA Tool, and then we're going to click Edit. Taking a closer look using our visual tool editor, you can see that here we're using a Docker image called Verse, which is hosted on the Rocker website. The reason I chose this image is because it allows me to write out a report using R. Next, let's look at the base command. You'll see the base command is just R script. It's telling the app that we want to run output report.r. You can see the full command at the very bottom here. So it's saying R script, and then it's telling the app to run output report.r. We have no arguments in this app, but we do specify the input as a CSV file. The ID here is labeled input_CSV, and it's a file type. The output is also specified. So here is a file that will capture anything generated as either an HTML or a PDF. We've specified hints to save the logs of anything in R as well, if you scroll down. So under hints here, we have save logs, and then *.r, so anything generated in R. And then lastly, you can see that we have 3 file requirements. Since we're running output_report.r, let's look at that one first. So you can click on this arrow to expand, and you can see that it's just a few lines, and it says that we are going to render script.r using input.r as a source. So we can take a look at script.r. So this is the script that contains the PCA instructions. It's a typical R script. And then input.r specifies the selected input file and connects it to our R script. I'm not going to go into too much detail here since it's a bit of JavaScript, but if you do have questions, feel free to please reach out to us or visit our office hours. Again, the link will be provided in the video description. Okay, we're going to modify this app today by adding an additional input. We're going to call it report type. To do this, we'll click on Add an Input under the Input Port section. And this will open up our side panel. So I'm going to change the ID to report underscore type. And then for the type, we'll specify that it's enum. So this means that the user of the app can only choose from the options that we're going to be specifying below. So we'll specify those under the symbols section here. We want the user to select a report type, and we are going to either give them the option of a PDF document, so I'll specify PDF document, or HTML document. Again, I'm just typing HTML document to specify. Okay, so now that we've added this as an option, let's save and make sure you add a note to yourself. So added report type as input, and then click save. Once we're ready, let's hit run, and we'll be taken again to a task page. So again, you can see the option for selecting a dataset here, but now we have an additional app setting that wasn't there before. The user can choose whether they want a PDF document or an HTML document to be generated. And whichever one the user chooses will be the output once we click run. This was just a quick example to give you an idea for how to edit an app. You can make apps as complicated or as simple as you'd like. If at any point you'd like to run a previous version of an app, so let's click on this PCA tool again, and let's say you want to run the original version. You can click on the revision and go to the original here. So created an app, and this will remove the app setting. So again, I'm going to go to the newer revision to show you that we'll have this additional app setting here called report type. And then if we go to the original revision, there is no app setting. So feel free to reach out to support if you have any questions at all, or visit us during office hours, and we'll be happy to help you out. For now, we'll be showcasing two great projects by Dr. Daoud Mirzman's lab at the NCI's Center for Biomedical Informatics and Information Technology, or CBIT for short. One item is a multi-step workflow called MOPA that performs gene set analysis based on multiple omics data. Originally available as an R package on Bioconductor, this workflow and its construction process on the CGC were documented and recently published in the journal Cancer Informatics. In addition to the article, the Mirzman group created a detailed workflow user guide that is available both in the article as well as on the CGC. A special thank you to Trin and Zhao Peng for collaborating with the CGC team on this. To get to this workflow on the CGC, navigate to the top blue banner and click Public Projects. The CGC maintains public projects which act as repositories for examples of specific analyses, as well as the associated data and tools you need to replicate these analyses on the CGC. Once you find your project of interest, click Copy Project, and at this point, the copied project becomes your own. You will have full project admin permissions and control over the project. Your actions in your own project will not affect the public project from which you obtained the resources. So let's scroll down and find MOPA, an automated multi-omics pathway workflow. Again, we're going to click Copy Project, to get our own project here. Once we've copied the project over, let's navigate back to the blue banner and select Projects to find our own copy of MoPA. Select this project. From here, you'll be taken to a new dashboard space. On the left, we have the project description, and on the right, members of this project. We can easily invite new members to this project by clicking Invite New Members and searching for their username or email address. Scroll down for additional information about this project. Here we have information on the type of data that is used as an input and steps for running this workflow. You can see that this workflow consists of two sub-workflows. One is data preparation and multiple factorial analysis, and the second is pathway analysis. This project provides detailed information for first-time users. You can follow the steps described to run the workflow. So we've copied the project. We can upload our own data files or run the example data files provided, and then click Edit and Rerun from the sample tasks. Once we've run this project, several results are generated. So we have diagrams, histograms, scree plots, and more. There are additional files that are generated as well. So all of these are .csv files that can be viewed within the platform. If at any point you're confused, you can click on the user manual, which I'll be opening in a new tab, to find detailed information. Switching back to the tab, let's take a look at what is in this project. So if we select the Files tab along the top, we'll be taken to all the files that come with this copy of the project. These include the user guide. Click on Apps, and we can see how this project was constructed. So again, we have the data preparation and MFA analysis tool, as well as the pathway analysis tool. Clicking on any of these will take us directly to the tool so you can see how it works. Public projects also come with preloaded tasks, so you can see how this was run. So you can click on data preparation and MFA analysis to see that it requires a database, a dataset, and a second dataset, as well as a metadata file. Once you're ready, you can click Edit and Rerun to try running the tasks on our own. So all of the input files are already preloaded here. You may change them if you'd like to run your own files. And for the app settings, you'll just have to specify what type of dataset you're running. So dataset 1 is an RNA dataset. Dataset 2 is a protein dataset. You'll have additional options here as well, like whether the protein needs imputation for missing data, and whether you are using raw RNA or normalized RNA. Once you're ready, click Run, and an instance will be queued. Once this task is completed, we can navigate to Files and scroll down to see two folders. One is RNA Protein QC Output, and the second is RNA Protein MFA Evaluated Step 2. You can click on any of these folders to see some of the results that are generated. For instance, I'll click on RNA log transformed. So this is the metadata view, which you can see is not filled in, but if you click on raw view, so we have gene names on the rows and samples as columns. A description of the outputs generated from the MFA analysis are also on the dashboard. So we can expect a Venn diagram, a histogram of global protein, as opposed to RNA, a scree plot, and a table of percentages. So you can click on either of these using these links or navigate to the Files tab and then go through the folders. So clicking on RNA protein QC output, we can see a Venn diagram, 2 histograms, and more. So I've opened these in new tabs. So this is the Venn diagram. We have a histogram that's generated of RNA normalized counts. A histogram that's generated for protein. This is a scree plot showing percentages attributed to each PC. And then lastly, total percentages. The second part of this workflow is the pathway analysis step. So again, we can scroll back up, click on Apps to find the Pathway Analysis app. Now for this tool, the outputs from the MFA analysis will go in, and then this tool will run to generate heat maps. Again, we can click on Tasks to view this task already completed. So let's click on Pathway Analysis Run to see what that looks like. Again, we have the database as an input, an expression matrix, and a subtype file. We can click Edit and Rerun to generate a new task with all the files preloaded once again, and then click Run once we're ready. Since this has already been run, we can see the outputs are in the directory for RNA protein 3 PCs. So let's go back to the Files tab, scroll down, and look for RNA protein 3 PCs. So we can click on Result to find several different text files and CSVs. Remember that the results for the pathway analysis are generally heat maps if you want to see plots. So we have 2 heat maps that are generated. One is representative significant pathways across subgroups by individual total gene set scores across common samples. The second is representative significant pathways across subgroups. So we have median of total scores as well as each data type score. Remember, if you're unsure, check out the user manual or click the question mark button to contact support. Clicking the cloud icon will take us back to our main dashboard page. Now, the second item I'd like to show you is an R-Shiny app called Omics Circos that generates high-quality circular plots for visualizing variations in omics data. This was originally developed by Ying Hu in R, and this tool was adapted for the CGC for an easy-to-use point-and-click interactive app. To get to Omics Circos, click on Public Apps along the top blue banner, then go to Interactive Web Apps. From here, you'll be taken to a new page with some of our R-Shiny apps. We have several to choose from: the dbGaP Submission Form Suite, Genesis Model Explorer app, Locus Zoom, and finally, Omics Circos. Click on Open. From here, you'll be taken to a new splash page. Click Yes to proceed. So this is the Omics Circos main splash page. We have a user guide available, as well as references that use this plotting tool. Once you're ready to start, click Start Discovery. So for Omics Circos, the first thing you'll do is input data. You can choose from your own data from several of your projects, or use packaged built-in data. Today, I'll be using the built-in data. So I'm going to select this to turn it on, and then load data. For segmentation data, I'm going to choose the HG19 human coordinates. Click on Load Data, and a pop-up will appear saying Data Loaded. Next, we'll select Mapping Data, and again, for this data, I'm going to use the built-in data. From here, I'll select maybe TCGA, BRCA, expression data. Once ready, click Load Data. Next, we'll use link data. Again, I'll be using some built-in data. So for this link data, I'm going to choose the TCGA, BRCA sample names, and subtypes. Then click Load. Once ready to create your plot, click on Visualizations. There are several plot types available, and you can stack these. To start, let's click on the chromosome plot. So it'll ask you to choose segmentation data, mapping data, and a column from mapping data to plot. So I'm going to choose the loaded data that we selected. For mapping data, I'm going to choose the gene expression, and then I will plot name. You can modify the circle radius or width, and then choose specific colors. I'm going to use the palette picker and use a rainbow palette. Once ready, click Submit, and a new plot is added. If you'd like to visualize this, click Generate Plot. From here, we can build upon this and add more information. For instance, let's click on Heat Map. Again, we will use our same data types, and then again, I will use chromosome to plot. Using the same palette picker, I'll click Submit, and once again a new plot is added. To generate this new plot, I'll click the button, and both the plots are overlaid on top of each other. We can modify this to visualize it a little bit better. So let's change the circle radius to something smaller, like maybe instead of 400, we will choose 300. Click Submit, and let's regenerate the plot. And now you can see two distinct plot patterns. From here, we can keep adding different plot types using the same format. You could add as many or as few plots as you'd like. At any given moment, you can edit these, or go to General Plot Settings to give it a name. So let's say Tutorial Plot. You can set a title for your X and Y axis, and change the aspect ratio. Once ready, click Refresh Plot, and you'll see the name appears. You could add legends or labels. A little bit hard to read, so let's change the radius of this and regenerate this plot.